Hello. Today we have a third last nail about solving imaginary problem of Stack Overflow, and today we'll talk about so-called CPS, which means Continuation Passing Style. What does it mean, how it can be applied to code for solving this problem, and all the related stuff. And first of all, we will not talk about so-called real continuations, which are very strong magic which used in scheme language. With keyword call CC, call is current continuation, which remembers the current snapshot of the stack of all the state of program and so on and so forth. So with a slightly less magical things, but still interesting, I think. And we will analyze them on a very simple example. I mean implementation of regular map function on a strict list. So let's look into the code. The naive implementation of function mymap is quite usual. If a list is empty, then return nil, otherwise return cons. It's a constructor of list, strict constructor. Let me put your attention on it, of f on head of list, and then recursive call mymap on tail of the list. Without any lazy sequences, without any laziness at all, just strict data structures into the memory expanded. So we will not talk about memory saving here, but we will talk about solving Stack Overflow problem. So that's why I implemented this function mymap, working on a strict data structures without any magic of laziness. Yep. And we will have so-called check calls, lazy range, yeah, of course, on an input, then strict map it by increment function, and then string representation only just for avoiding limiting my REPL view of the result, because my REPL limits of value of first 10 or 20 values of even strict lists. So let's evaluate it first. And here we have strict map. Let's call it on a small list. Yeah, from 0 up to 9 it returns 1, 2, 3 up to 10. Yeah, but from 10,000 it fires Stack Overflow. Why it happens? Because here it's not tail call, it's not tail recursion. We cannot use here a keyword recur and so on, because it's not a tail call, because we have to do some operations on the returned value of my map function. Yeah, we have to cons some value to it. But yeah, of course, we can do some tricks. For example, we can implement a map in a tail recursive way, as shown here. Internal tail recursive function which calls return and have a so-called accumulator. But it will work slightly interesting way. Yeah, it returns the list but reversed. And yes, it will not fire the Stack Overflow, but again it returns the reversed list, because we accumulate the result in special accumulator as a function argument, but we started from the beginning, and this beginning becomes the end of the list actually. That's why it returns a reversed list. Of course, we can reverse it again, using the same map by identity function, and that would be a trick. We avoid in Stack Overflow and using a tail call on a map function, and actually in my Lisp implementation I did this way. So my library function map use actually internal map twice for avoiding reversing list. And in some lists there are two different standard library map functions, so-called regular map and reverse map. And reverse map slightly more effective because it has only one run through all the list. But the main question is how we can keep the order of a list on one hand, and avoiding Stack Overflow on the other hand, and third time, do not use any lazy tricks, any laziness and so on and so. So that's why, and that's when continuation passing style came. Continuation passing style is a special way of writing programming code. It's a slightly complex way, as opposite to the regular one, but it allows us to do some tricks. What do I mean? As a good analogy, I can show you it this way. Instead of a direct evaluation of functions, first of all, we construct a big, huge lambda. And then, at the total end, we will call this lambda on some arguments. And the evaluation of a big code actually evaluates a one big lambda, which has all these internal calls inside of it. And all the continuations will pass through this lambda in a calls which are actually tail calls. So that's why we construct this lambda. All the calls inside this lambda are actually tail calls. And that allows us, in a world where we have a real tail call optimization, that allows us to avoid a Stack Overflow on any recursive function, even not tail called. So let's show it on my ListScript view, because it's my ListScript evaluator, and it already has built-in TCO, tail call optimization. So there are two lists, list A from 1 to 10, list B from 1 to 5000, and two map functions, naive map, as we've seen before, and so-called map with CPS style, map with continuation, internal function go, which returns some value, and in its input arguments there is so-called cont, continuation, actually a lambda. Then we wrap this continuation in another lambda, and so on. So let's first of all call naive map on increment on short list. Yeah, 2, 3, 4 up to 11. Yep. But if we call naive map on long list, it returns Stack Overflow. Yeah, but then let's call continuational map on short list. It returns the same value. And continuational map on long list, wow, it returns without Stack Overflow. Yep, and it works. But let me remember that this trick works only if you have already built-in tail call optimization. But let's return to the closure and try to recreate this behavior. We'll implement the continuational passing style map function here, evaluated, trying to run it on short list. But yeah, on the long list it's also fires Stack Overflow, and I hope you guess why. Because Clojure doesn't have built-in TCO, tail call optimization, on itself. But on the previous nails we discussed it, and we found out that we can use a trampoline for emulating the tail call optimization. Our own custom bare bonus trampoline macro and deval trampoline function, and we can wrap this CPS style even in trampoline just to emulate tail call optimization over the continuation passing style code here in the Clojure. Let's see how it looks into the code. This continuation calls here and there. We just add a trampoline macro before it, and then on the returned value we wrap it into eval trampoline call. And actually it works. Let me show you. I'm gonna go again here. And yeah, finally we win. because it keeps the order of the values in our sequence, in our strict list actually, and it doesn't make two runs over the list, and it returns the actual mapped list by increment. So it works, but in order to to make it work, we had to do two tricks. First of all, we had to write the code into a continuation passing style manner, and then it's not enough if we do not have tail call optimization. We had to add additional explicit trampolines here. Yeah, actually, this approach used in OCaml language for avoiding Stack Overflow. First of all, there is a sum optimizer which converts any code to the continuational passing style CPS way, and then on the top of it there is another optimizer which optimized it in a manner to avoid the tail call Stack Overflow, so produce the tail call optimization. So then maybe that's up for today's nail. See you on the next one.